Hi, my name's Jason Miller, and I live in the Chicagoland area. And for the last 7 years, I've worked as a pre-sales solutions engineer for Tableau. But I'm looking to transition into a role as a data analyst where I can work more on a day-to-day basis with data, doing analysis, solving real-world business problems, rather than being a little more focused on selling tools, analytics tools, which was what I was doing. So I enrolled in a data analytics and Python bootcamp through Savvy Coders, and I've spent the last 3 months improving my Excel skills in Excel, uh, SQL, Python, as well as Tableau. I also, as part of that program, have completed this Capstone project. And for the topic, I chose Chicago crime. And the reason being is one, it's a local issue for me. I born and raised in the suburbs and lived for a significant period of time within the city. And Chicago is, near and dear to my heart. Crime is constantly in the news and a topic for Chicago. The Chicago's known for its high rates of crime, particularly homicides and gun violence. In fact, Chicago has led the nation in the number of homicides for the last 11 years. Although it is interesting to note that if you look at the actual crime rate, there are quite a few cities that have higher rates, but they're just smaller. And then lastly, I have come across in the past, just being in the data and analytics community and local to Chicago, the crime data set that the city of Chicago publishes. It's really an excellent data set. They publish every single crime incident or record of crime that occurs on a daily basis. And that goes all the way back to 2001. And I thought it'd be very interesting to work with that data set. Um, as I did some research and tried to formulate what my research question would be, I found out that there are a number of causes or variables that influence crime, both in the city as well as urban areas in general. The FBI has identified um, economic conditions such as poverty rate and median income, some cultural factors, family conditions, divorce, single parent households, population density, etc. And what I want to do is see if I could combine the crime data with some census data to see if I could find those correlations within the different neighborhoods of Chicago. So my research question was, what are the correlations between crime rates and demographics in Chicago community areas? So I had two primary data sets. The first one is published by the Chicago Data Portal, or it's available on the Chicago Data Portal, and that's the crime data. As I mentioned before, single row for every single incident that's reported in the city goes all the way back to 2001. Currently, there's about 8 million rows of data. For the census data, I found a data set published by the Chicago Metropolitan Agency for Planning, and that one has over 223 different demographic, land use, economic, all sorts of different metrics that come primarily from the American Community Survey that's done by the US Census. And all of that data is aggregated at the community area level for the city of Chicago. Chicago is broken down into 77 different community areas, and there's a row of data for each community area. In terms of manipulating the data, wrangling the data, cleansing the data, I used a number of tools, including Excel. Spent a lot of time in Excel, just cleaning out data that I didn't need, creating calculated fields to compute ratios and percentages that were more useful than the uh, num raw numbers. Um, and with Python, pandas, I did some initial exploration of the data, connected with the JSON API that is available. And probably the most crucial point was I used pandas to compute the correlations between the crime rates and the demographic variables. I use SQLite to join the two data sources, aggregate the crime data at the community level, and calculate the rates of crime for the different crime types. And I used Tableau at the end to do a couple of one-off joins that I needed, and primarily to join the Esri shapefiles for the community areas with the demographic data and the crime data, so that that can be displayed on a map. So the first thing I did was I tried to connect to the crime data using the API that's available. And I was able to successfully connect. I accessed the data in JSON format. I was able to connect it to convert it to a data frame, and successfully uh, filter the data and use some specific parameters and that kind of thing. But the problem I ran into was I couldn't access more than 1,000 rows at a time. So I went ahead and just downloaded all the data in a CSV and connected that into Python. Was able to convert that into a data frame. Just did some preliminary analysis of the different columns, created some visualizations using matplotlib. Here we're looking at the frequency of different crime types. Theft and battery are the most common. This is the overall trend of crime over time. You can see that crime is definitely going down. But as I learned later in Tableau, if you look just at the homicide rate, that actually is increasing in recent years. Next, I accessed my data, downloaded the US Census data for the community areas, and did some cleansing in there. You can see, as I mentioned before, there's 223 columns, so a lot of different variables. Some of it's relevant, some of it's not. So I had to spend a lot of time going back and forth with the data dictionary that they published. Fortunately, they did publish a good data dictionary to figure out what all these columns represented, so I could decide which ones I wanted to keep and which ones I wanted to get rid of. I also spent a lot of time computing ratios and percentages from the data. So most of the variables in the data set were expressed either in the number of people or the number of households for that variable. So what I would have to do is convert that to a percentage for each community. So in each row, I had to divide the number of people that had no vehicle, for example, by the population for that community, and calculate a percentage so that I could meaningfully compare and calculate those correlation ratios for each community. In SQL, I had to take the crime data set and filter that down just to the years that I was interested in, and then aggregate it at the community level so that I could calculate the number of incidents of crime for each community, as well as the percentages. And then I took that and then I went and re-imported that into my data file in Excel that had my demographic information, and that allowed me to have all of the crime rates along with the demographic variables. The last thing that I'll mention is the correlations. So once I, in Excel, isolated just those columns that I was interested in finding correlations for, I imported that into Python and used pandas. It really only required a few lines of code. And what that output was a correlation matrix with every single crime rate and demographic variable. And along the x-axis, you had the same thing along the y-axis. And then for the numbers, you have the correlation coefficient, so how strongly they're correlated. The way the correlation coefficients work is the closer the number is to 1, the stronger the correlation. The closer the number is to -1, the stronger the negative correlation. And then the closer it is to 0, the weaker the correlation. There is no correlation. And I went ahead and displayed a heat map of that correlation matrix using Seaborn in Python. And you can see here, it's a little hard to read. There's a lot of variables. It wasn't even able to display each of the variables. So the darker the blue, the stronger the positive correlation. The darker the red, the stronger the negative correlation. And the closer to white, the weaker the correlation. So then I exported that correlation matrix. I used Excel to unpivot the data so that I could have it in a tall format for Tableau. And then I did the analysis in Tableau. So the first thing I did was I just wanted to get a general idea of what the distribution of the different crime types looked like in the city by neighborhood. So you can see here, I've got a column here for each type of crime, from all crime together to homicides, violent crime, property crime, drug crime, and other crime. You can see at a glance here that drug crime is very concentrated in just a few different neighborhoods. I also noticed that homicides and violent crime, as well as other crime, seem to be very highly correlated with the overall crime rate. Property crime, a little bit less so. And then in this bar chart at the bottom, you can see the individual crime rates. Each bar is the crime rate for a particular community area, and you can sort it by the type of crime. So you can see that in general, they're all pretty, different types are pretty highly correlated, other than perhaps drug crime. And you can see some outliers that stand out. So for example, the Loop, which is the business center, that's where all the skyscrapers are. That one, even though it's pretty high in overall crime, extremely low in homicides, as well as low in violent crime, pretty high in property crime. All right, so this is kind of the meat of the analysis. So what we're looking at here are all of the correlation coefficients along the x-axis. In the columns, we have the different crime rates for all the different types of crime. And then along the y-axis, or in the rows, we have all of the different demographic variables that I computed the correlations for. And then the longer the bar, the stronger the correlation. And the colors represent whether or not it's a positive or a negative correlation. So I'm actually displaying the absolute value of the R values. So you can just see the overall strength of the correlation. And then if it's red, then you know that that's a negative correlation. The lines here, the reference lines, indicate whether or not this is a strong correlation, a moderate correlation, or a weak correlation. It's a little bit arbitrary where you kind of set those measures, but I decided to set a strong at 0.75, moderate at 0.5, and a weak at 0.25. So the first thing you'll notice is if we go off of this guide, that we've got, probably over a dozen different demographic variables that are either moderately or strongly correlated with crime. The number one variable is vacant housing unit percent. So this is the number of the percentage of either apartments or houses that are vacant at any particular time. So that's pretty interesting that that's the number one correlation. Next is unemployment rate, which isn't that surprising. The percent of the population that's Black. So the census breaks down race and ethnicity by Black, Hispanic, white, Asian, and other. And unfortunately, in terms of African Americans, Chicago is still a very segregated city in terms of communities, and there's a lot of very majority Black communities versus other, and those communities tend to have higher crime rates, poorer schools, probably more vacant housing units, vacant land, et cetera. And then the last one I'll point out here is income less than 25K. So that's a measure of poverty. I also looked at income less than 50K, and I think 100K, and then over 150. And the number one correlate relative to income was the percent of income less than 25K. Equally interesting is if we look at those variables that had negligible or no correlation with crime. One of them that was a little bit surprising was the percent of the population that was 16 to 34. So it's sort of well known that that age group, 16 to 34, tends to commit the most crimes, but that didn't seem to have an effect. A few variables here on land use. So open percent, not sure what that one is, but commercial use, industrial use. So that's the percent of the land that's commercial, industrial. That doesn't have any effect. Median age didn't. And then the other one that's surprising is less than high school percent. So I would have thought that the percent of the population that's a high school dropout, that would be more highly correlated with crime rate. And turns out that the R value is not, but there's a caveat, which I'll point out at the end, that there is a relationship there. It's just not, it's not immediately evident and not linear. Okay, and for the rest of the analysis, I pretty much broke up the variables into four different categories: economic, housing, education, and race and ethnicity. And I'm not going to go through each one, but this is more of an exploratory analysis where you can, on the map, select the type of crime, and then you can select the demographic variable, and then I've got these scatter plots for each one, and then the correlation matrix in the lower right. So this correlation matrix has the different crime rates on the left. It has the demographic variables on the top. And in the middle, these are the correlation values. So these are the R values. As I said before, the closer to 1, the stronger the positive. The closer to -1, the weaker, the darker the blue, the stronger the correlation, et cetera. So we can see here unemployment rate, that was very highly correlated with overall crime. And you can see mapped this one, 0.83 for the homicide rate versus the unemployment rate corresponds to this square and the scatter plot. And the scatter plot's set up the same way. You've got the crime rate on the y-axis and the demographic rate, the x-axis, and you can see that this is very closely correlated with that line. One thing that I noticed that was pretty interesting to me is if we look at median income versus the homicide rate, for example, you can see this very clear trend where there's a sharp downward slope until you get to about 60,000. And then once the median income for that community is higher than that, then it levels off, and there's pretty much a very low crime rate. So what this says is that there's kind of a threshold that once you get below 60,000, then that's when, as a median income, that's when your community is going to start to have problems. And this is also an example of where the R value may not reflect the strength of the correlation, because this is not necessarily a linear correlation. So this is linear here, and then this is linear here, but it's a pattern that's not linear. So just kind of an interesting insight I found there. And then if we look at education, you can see that if we look at this correlation matrix, this less than high school percent, very, very weak correlations here. So crime rate versus less than high school percent in the upper left corner here, very weak correlation, but you can see a very definite pattern. So it looks like we have a population here that is potentially a linear correlation, and then a population down here, and it kind of expresses itself in some of these other ones. So I wanted to kind of drill down into that. So I did just a little bit of an ad hoc analysis, and I took the less than high school percent, and I brought in some other variables, demographic variables that potentially could be related, that were strongly related to crime. And you can see here that if you look at the percent Black, if I take, first of all, there looks like there's a cluster here. There's two kind of clusters. And if I take the communities that are more than 50% Black, and then I look back at this less than high school percent versus crime rate, that then we have this very strong correlation here versus the communities that are non-Black. So it's very possible that there are correlations in this data that if you look at the majority Black communities separately from other communities, that there would be stronger correlations, but ones that you don't have overall. All right, so in terms of conclusions, I was pleasantly surprised to see how many demographic variables were moderately to highly correlated to crime rates. The top ones being vacant housing units, the percent vacant housing units, unemployment rate, the percent Black, and the percent income less than 25K for household income. And there were a few surprising demographic variables that were weakly correlated or had no correlation. And that was some of the land use, percent industrial, percent commercial, percent age 16 to 34, as well as the percent that had less than a high school education. Some other call outs are that some of the correlations are not linear. So these are not going to be reflected in the R values. One example of that would be the percent less than high school, as well as some of the income demographics, median and income, that sort of sharply dropped until you reached 50 to 60K median income, household income, and then leveled off. And then lastly, that insight that I had found that some specific populations, notably those communities that are majority Black, seem to have correlations with some variables that don't exist in the broader population. So it would be worth doing some additional research and seeing which of the demographic variables are correlated to majority Black populations and vice versa. Okay, so that concludes my presentation. I appreciate you taking the time to watch. I hope that you found something in here that was interesting and valuable. I hope you have a great day.